Welcome to this M1 video on inclined planes. Now, you saw in the previous video when we had objects on like horizontal surfaces in general. So something like this, and if they were pulled at an angle, then we resolved that both vertically call that 40 degrees and horizontally. Okay, now today when we look at inclined planes is going to be a little bit different. So when I look at an inclined plane, say like this plane here, if we call that 20 degrees. Now, if I have an object on that plane, like a particle, or let's make it a box for now, then like on the normal plane, this had a normal reaction that is perpendicular to the plane or straight up. Now this normal reaction is like this, is perpendicular to the plane. Okay, so if I have forces acting upon this box, like for example its mass, or if there's another force, say, going parallel to the plane straight up, then what I need to do is I need to resolve these forces so that they are either parallel or perpendicular to the plane. So for example, if this one is 3 g newtons because it's 3 kilograms, then resolving it perpendicular and parallel to the plane would give me this. So this is going to be 90 minus 20, so 70 degrees. So this one is going to be 20 degrees. So this would be 3g cos 20, and this one would be 3g sine 20. Okay, so that's kind of what I'm going to be looking at today. So we're always going to resolve parallel to the plane or perpendicular to the plane. Okay, so we're not going to look at resolving horizontally and vertically. It's going to be parallel and perpendicular to the plane. So, in line with the plane and at 90 degrees to the plane. Now, what I think we'll do is we'll jump into just a straightforward example first of all and take it from there. So here we've got a block of mass 15 kilograms slides down a smooth sloped plane at angle 30 degrees to the horizontal. Okay, now before I go ahead and start working these out, if I haven't got a diagram, I need to draw a diagram. Okay, because I need to put on that diagram everything that's happening. So there's my diagram. Actually, I'm just going to move this down a little bit. Now we've got a block here of 15 kilograms. So that is going to have a weight acting down of 15g newtons, and normal reaction there acting perpendicular to the plane and 30 degrees. Okay, now what I've got to do is I've got to calculate the normal reaction, so R, and the acceleration of the block. Now it's a smooth sloped plane, so there's no friction to worry about. Okay, now I've just got to resolve this 15g newtons force. Okay, so this direction here, which is perpendicular to the plane, this angle in here is 30 degrees, isn't it? Because 30, if I take this down, that makes a 90-degree angle. So this is 60 degrees. And 60 plus 30 then give me this right angle. So this angle is 30 degrees. So this is 15g cos 30. And then the parallel to the plane is going to be acting downwards, and that's 15g sine 30. Okay, so that's acting down. You can see that this is more over to the left of the perpendicular than to the right of it. So you know when it splits up, you're going to get these two components of that force, and they're always at 90 degrees to each other. So there we have the diagram. This is what we need to help us. So for A, now R is going to be equal to 15g cos 30. Okay, because there's only this acting up and only this weight acting in that direction. So 15 times 9.8 times cos 30 gives me 127.3, which I'll just call 127 newtons to 3 significant figures there. And that was resolving perpendicular. So let me just make a little bit of space. Like that. Now we want to find the acceleration. So now we're going to resolve parallel with the plane. Okay, now I can do it going up like that, but I know this is sliding down the plane, so I put my arrow going down because I want down as positive. Okay, so F equals ma. The force is only one force, it's 15g sine 30 equals 15 A. So 15 times 9.8 times sine 30 gives me 73.5. Divide by 15, and A is 4.9 meters per second squared. And that there is the acceleration. And I hope that you followed me just with resolving. So you resolve your forces into parallel and perpendicular to the plane, and then when you do the questions, you split your forces up into the parallel and perpendicular components, is a better way to say it, and then we resolve then either parallel or perpendicular to the plane. Okay, let's have a look at a second example. So here we have a particle of mass 4 kilograms is moving on a smooth slope and being acted on by a horizontal force of 5 newtons, as shown. The slope is inclined at an angle alpha to the horizontal, where tan alpha equals 4/3. Work out the acceleration. So first I'll just take this diagram, just move it down a little bit so I've got a bit more room. And then we need to add a few things to it. So we need to add the normal reaction. Okay, and we need to add the mass. So the mass is 4 kilograms, so it's 4g acting down. Okay, now we need to resolve our forces. So we need to split our forces up into their components. So for the 4g, that's going to act down this way and this way. Okay, so this is 90 minus alpha, so this is alpha. So this will be 4g cos alpha and 4g sine alpha. Now, for the 5 newtons, you imagine it's this side of the thing because it's just pushing into it. So when I resolve it, it's going to be up and down. And there's alpha, so there is alpha there. So I'm going to redraw it just across like this. 5 newtons there. And then acting up the plane, well, this will be alpha, won't it? So it's going to be 5 cos alpha. And then acting this way will be 5 sine alpha. Okay, so there now I have all of my forces. Now I don't need to work out the normal reaction in this case, I just need to work out the acceleration. So for this I'm going to resolve, and I'm going to resolve like up the plane. So I'm going to assume it's going up. So that's going to be F equals MA. So going up the plane is going to be 5 cos alpha, and then going down the plane is going to be 4g sine alpha, and then this is going to be 4a. So I also need alpha. So to do that, tan alpha equals 4 over 3. So I can work that out. I can work out what alpha is by doing, the inverse tan of 4/3, and I get 53.1 degrees. Alternatively, I can think of this logically. And if this is alpha and tan is opposite over adjacent, I get this. And with Pythagoras, this is 5. Therefore, sine alpha is opposite over hypotenuse, and cos alpha is adjacent over hypotenuse. So I can use these fractions then rather than stick the angle in. Okay, but it will give me the same answer either way. So this is 5 times 3/5 minus 4g times 4/5 equals to 4a. So 5 times 3/5 is just going to be 3, and 4 times 9.8 times 4/5 is going to be 31.36. So I think we can see now that actually this is going to accelerate down the slope. So 3 minus that is negative 28.36. Divide by 4. We get that the acceleration is minus 7.09 meters per second, or accelerates at 7.09 meters per second down the slope. Okay, so in this case, even though there was a force pushing it towards up the slope, its weight was much heavier, and so overcome that force, so it actually still moved down the slope. Okay, but as long as you just take a direction as positive, then the sign will just tell you the direction that you're going, and the values will still remain the same, so there's nothing to worry about there. So hopefully you could follow that. I know there's quite a lot of information on this diagram, and like when I get forces like this, sometimes I do find it easier, because when the arrow is pointing towards the particle or the object, I do find it easier myself personally to draw it the other side so it's coming out from the particle. I find it easier to resolve then, because you're resolving it from the particle. If I was going to try and resolve this one from the particle, it would have been a lot harder to think it through. Okay, so just taking, when you've got like a force pushing against the particle, to take it to the other side as if it's pulling. And that way then it's easier to resolve your forces. Okay, so I think that's all I'm going to do in terms of examples. So if you found the video useful so far, smash that like button. If you're yet to subscribe, subscribe. And if you're willing and able to help me out financially, hit that join button. Even if it's only for a month, every little bit helps. Otherwise, let's look at the questions. So I've got 5 past paper questions for you today. As always, there might not be full past paper questions, just, a section of the past paper question that applies to what we're doing. Okay, so here's the first 3. So pause the video now. Okay, and let's look at the next 2. So here's the next 2. So pause the video now. Right, welcome back. Hopefully you've had a chance to have a go at these. Hopefully you didn't find them too challenging, but let's look through the solutions. Okay, so we've got a 6 kilogram mass on a slope. So let me just draw my slope. Okay, so 6 kilograms. That's a normal reaction. A 30 Newton force is pulling the particle up the slope. So that means this is a 30 Newton force and it's inclined at 15 degrees. The force acts in the direction of motion. It's just pulling it up the slope. The force of 30 newtons is pulling a particle up the slope, so it's moving up the slope. And then this particle experiences a constant resistance force due to friction. So resistance is in the opposite direction of motion. And we'll use F for friction there. Okay. So since the frictional force and the 30 Newton force is parallel to the plane, I don't have to worry about those. What I do have to resolve is this weight, which I'll do in red here. So this is 6g cos 15 and 6g sine 15 going down the slope. Okay, so there's my forces all on my diagram now. Now I can go ahead and resolve. So resolve up the slope, and we got F equals MA. Okay, so going up the slope is a 30 newtons, and going down the slope is 6g sine 15 and F for friction. Okay, I might call it FR. And then the mass is 6 and the acceleration is 0, isn't it? Because we're going with a constant speed here. So that means I've got 30 minus 6g sine 15 equals that FR. So FR is 14.8 newtons to 3 significant figures. So there we have the first question done. I think you'll agree it's fairly straightforward. Hopefully you managed to get this answer out. Right, let's move on to question 2. So question 2 has a particle of mass m sliding down a smooth slope that is angled at 30 degrees to the horizontal. So I want to draw a diagram first of all. Always in mechanics, always draw a diagram. You don't have to draw it like with a ruler like I am now. You can just draw a sketch just to put the information into the diagram. It really does help you answer, and if you start doing it on all the questions, even the straightforward ones where you don't really need it, then you'll get yourself into a nice good habit. So this is mg. Now the normal reaction between the plane and the particle is 5 newtons. So this R is equal to 5 newtons. Okay, calculate the mass and then calculate the acceleration. So in terms of the mass, this is going to be mg cos 30 and mg sine 30. Are you happy with the cos 30 there? Because this is 30 degrees, yeah? Remember, cos of the angle that you know, and then it would be sine of that other angle, okay? If I was going to use this angle here of 60 degrees, this would be mg cos 60, okay? And sine 30 and cos 60 are the same. Okay, so it always works out. Right, so for part A, we're going to resolve perpendicular to the slope. So R equals mg cos 30, and R is 5 newtons. So m is 5 over g cos 30. And that is 0.589 kilograms to 3 significant figures. Now, I will store that in my calculator as A. Just put a little A there to remind myself. And I do this when I solve questions myself. I store the full answer in my calculator, so that I can easily recall it later. If you're not sure how to do that, just check out one of my shorts. I think there is one in there for storing values in the calculator. Now we need to calculate the acceleration. So for this we are going to resolve vertically downwards because it is sliding down the slope, and we're looking at F equals ma. So F, there's only one force, it's mg sine 30. This is m and this is a. So a is 4.9 meters per second squared. This one was quite easy because actually there was an m on both sides, so I could cancel the m's out, so a was just g sine 30. Okay, so there is both of my answers, and again a nice easy question. Again, this would have been just part of a question in a previous exam. Now let's have a look at question 3. So we've got a force of 30 newtons acts horizontally on a particle of mass 5 kilograms that rests on a smooth slope inclined at 30 degrees to the horizontal as shown. Find the acceleration of the particle. So we've got this diagram. I've just copied it from up there. That is my normal reaction. This is 5g. And this 30 newtons I'm going to take to the other side. and I'm just going to rub it out from here. Okay, so there now I have all of my forces on here, and I'm going to resolve them both perpendicular and parallel. Start with the weight, so this one is 5g cos 30, and we've got 5g sine 30 there. And then I'm just going to go into purple and do the 30 Newton. And this is 30. Now, this angle here is the 30 degrees, isn't it? Because it's the horizontal and the slope, horizontal and the slope. So this is 30 cos 30. And then this direction, it'll be 30 sine 30. Now, in this case, we don't need to find the normal reaction, just the acceleration of the particle. I don't know whether it's accelerating up or down. It looks like it's probably accelerating downwards, but I'm not sure. I'm going to take upwards as positive. So F equals ma. I'm taking upwards as positive. So it's 30 cos 30 minus 5g sine 30. And the mass is 5 and A is what we're trying to find. Oh, and it is up. So this is 1.48 to 3 significant figures. I'll store that as A. And then divide by 5. And we get the acceleration is 0.296 meters per second squared to 3 significant figures. Okay, so the particle accelerates up the slope at 0.296 meters per second squared. Okay, so just make sure you do that on there, or adding your positive direction onto your diagram. It can be assumed from the values you've taken as the up with the slope and down the slope, but I think just err on the side of caution and either state it at the end or make sure you state the direction you're taking as positive, within the diagram or within your working out. Right, let's have a look at number 4. Okay, in this question we've got a particle of 3 kilograms moving on a rough slope that is inclined at 40 degrees to the horizontal. A force of 6 newtons acts vertically upon the particle. Given that the particle is moving at a constant velocity, calculate the value of F, the constant resistance due to friction. Okay, so we've got this, and then this is a 3 kilogram, so 3g newtons acting downwards. And then we've got F, which is the resistance force due to friction. Now, we're not told whether this is moving up the slope or down the slope, so at the moment, I can't say which way the resistance, the frictional force is acting, because the friction always acts opposite to motion. So what I first need to do is resolve these forces. So if I do the 3g one first, okay, this is going to be 3g cos 40 and 3g sine 40. Okay, this is going to have a normal reaction there, but from the 6 Newton force it's going to act that way and that way, isn't it? Okay, so now we need to work out what angle. So to do this I just need to think about it logically. Like this will make a 40-degree angle with the horizontal. So this is 50 degrees, which means that this is 40 degrees here. So this is now my 40-degree angle. So this will be 6 sine 40, and this will be 6 cos 40. Okay, so now I've got all my forces on here. I just want to do a quick little check. So 3 times 9.8 times sine 40, which is this from the weight, gives me 18.9, and 6 times sine 40 gives me 3.8. So this weight is a larger force than the force given by the 6 newtons. So as it stands without friction, this will move down the slope. So friction must be acting up the slope that way. So I call it FR. Okay, so now I've worked out which direction my friction is going, I can now solve this. So it's going at a constant velocity, so A equals 0, and we're resolving parallel with the plane. So that is 3g sine 40 minus 6 sine 40 minus the friction equals 3 times 0. So the friction is 3g sine 40 minus 6 sine 40. So in my calculator now, I get that the friction is 15.04. So this will be newtons to 3 significant figures. And sometimes what I will do before rounding it off, I will put down, a few values and then round it off. Okay, I do like to do it that way. But does that make sense? So, friction always acts opposite to motion. So first of all, you've got to see which direction this would be traveling if there was no friction. Okay, and this value is greater than this value, so it would be heading down the slope. So downwards would be, the positive direction, which is why I wrote the downward arrow here. Okay, so that is question 4. Hopefully you guys were able to do that one okay. Now let's jump on to the last question, number 5. So we've got a particle of mass m is pulled up a rough slope by a force of 26 newtons that acts at an angle of 40. The particle experiences a constant frictional force of 12 newtons, which is there. Given that tan alpha is 1 over root 3 and that the acceleration of the particle is 1, show that the mass is 1.08. So let's start off with the diagram. So here's my diagram. Let's put on my forces. So my normal reaction is there. This is mg. So resolving mg will give me mg cos alpha and mg sine alpha. Okay, so that is that one done. Then the 26 Newton force will go this way and this way. So this is 26 cos 45 and this one is 26 sine 45. Okay, because that's the 45-degree angle, although in this case cos 45 and sine 45 are the same thing. So now I've got all of my values on here. I can go ahead and work it out, but first let's look at the tan alpha is 1 over root 3. So like before now, what I can do is I can work out fractionally for the sine alpha and cos alpha, or I can just work out what alpha is. Now this is opposite over hypotenuse. So 1 squared plus root 3 squared is 4 square rooted, so that's 2. So cos alpha is root 3 over 2 and sine alpha is 1/2. So it's nice to be able to write down these values as fractions. Of course, you can work out the angle in the calculator and solve them. But when I was in school, you had to do it this way because the calculators couldn't do fractional values then, it'd only give you decimal answers. Anyway, that's a bit of history. So let's resolve this going up the slope as the friction is acting down the slope. Going up the slope, we have 26 cos 45. Okay, and then acting down the slope, we have the 12 newtons and the mg sine alpha. And then we have m times by 1. So 26 cos 45 gives me 13 root 2 minus 12. Well, I'll just leave it as 13 root 2 moment minus 12 minus mg, and then sine alpha is 1/2. So 1/2 g is 4.9. So this is 4.9 m. Take it to the other side will give me 5.9 m. And this is 13 root 2 minus 12. So m is 13 root 2 minus 12 divided by 5.9. And we get 1.08. 2165 and so on, which is 1.08 kilograms to 3 significant figures, which is what we were requiring there. Okay, so hopefully you followed that and it wasn't too challenging. Hopefully this will enable you to have a go at a few more questions. So have a go a few from your textbooks. You can have a go at questions, online, also using ChatGPT to create questions for you, or if you find a challenging question, ask it to create similar questions. Okay, but there we are at the end of the video. Don't forget to like if you found this video useful, subscribe if you're yet to do so, and hit that join button if you're willing and able to help me out financially, even if it's just 1 month. Every little bit helps. See you in the next video.